This video, we will be looking at different samples of igneous rocks. So igneous rocks are one of the three categories of rock types, the other two being sedimentary and metamorphic. Igneous rocks are rocks that are born from fire. So we're working with things that come from fire. Basically, they are literally molten or melted rock. So all of these lovely rocks here started out as liquid, right? We're talking about the difference between lava versus magma, and that's going to dictate a lot of the differences between our different igneous rocks. So all five of these samples here are igneous rocks. And as you can see, they all look pretty different. All right. So let's go through them one by one. One of the most popular examples of an igneous rock, let me go ahead and move these guys off screen, is this lovely fella here. Those of you who are Game of Thrones fans might recognize this as dragon glass. Or if you've ever done any Native American units in any of your California history, at least, this is, of course, obsidian. Obsidian was used extensively by indigenous peoples. So, for example, arrowheads, which, again, many elementary school students have studied. And of course, if you are an anthropology major. So obsidian, it has this lovely glassy hue to it. Okay. So it's nice and this black and shiny. You can see it's not shiny all the way around. But this nice shiny glass. In fact, if I were to break this, this is the sharpest point that man can naturally make is with obsidian. Hence its use for weapons. Now, what's interesting about obsidian, it's an example of what's called an extrusive igneous rock. Igneous rocks come in two different categories, and one of them is extrusive. An extrusive, think of extrusive as being external. Extrusive igneous rocks cool on the outside of the surface. Remember, igneous means born from fire. So all of these rocks are going to start out as being molten or melted rock. Yes, rock can be liquid, right? And that exactly is what magma and lava is. Magma and lava are just two different types of molten rock, right? Melted rock. So when I have an extrusive igneous rock, it means that the magma has been barfed up onto the surface of the earth, all right? Magma is melted rock when it's inside of the earth. It's on the interior of the earth. Lava is melted rock once it's been extruded or vomited up onto the surface through a volcano or other fissure or vent on the Earth's surface. Okay? So both melted rock, just inside the Earth, outside the Earth. Okay? So obsidian is an example of that extrusive igneous rock. All right, so it has been extruded or erupted out onto the surface of the earth. And what gives it this nice glossy texture is that it cooled very quickly. So think about a liquid substance when it gets put out onto the surface of the earth. It's going to be exposed to water and to air, and all that water and air is going to make it cool very fast. And that's why you get this nice glassy texture, is it had to cool very, very fast because it cooled on the outside of the earth. All right. So obsidian, again, a very classic example of an extrusive igneous rock, and one that you often see in areas that have a lot of volcanic activity because, again, when volcanoes erupt, you have all that lovely lava on the outside of the surface. So let's look at something that is the other category. All right. So not extrusive, and that's going to be what we call intrusive. And think of intrusive as being interior. So a wonderful example of this is granite. Da-da-da-da. You might have some of these in your countertops at home, very popular in kitchens across the world, right? Or just any type of fancy rock work in houses, right? So the interesting thing about intrusive rocks, sometimes volcanoes get lazy. All right. So let's say I have a volcano and it's going to erupt, and then it decides, I think I'm just going to order a pizza and stay in and watch Netflix. I don't really feel like erupting today. Well, you have all this magma that was ready to erupt and then it didn't go anywhere. Well, now it's just kind of snuggled inside the earth with nowhere to go. It's going to begin to cool. But because it's inside the earth, again, it's surrounded by all of that soil and dirt and stuff. It's going to cool a lot slower, right? So intrusive igneous rocks cool much slower than their extrusive counterparts. And they're going to be strictly magma, right? If magma is on the inside of the earth and lava is on the outside, lava is going to be your extrusive. Again, magma is your intrusive. So when I compare, and get this nice up and close in here. Autofocus. If you compare the granular structure of this rock, it's actually a little easier to see from down here. There we go. Aha. I can use computers. So if you look at how coarse it is, right, I can see all the individual little chunks of stuff, right? As little bits of pink and little bits of black and some sparkly, shiny things, right? All of those little pieces are going to be different minerals, right? So granite, for example, is made up of 3 different minerals, right? And so the pink in this one is going to be potassium feldspar. Not all granite has that pink hue to it, but this one does. So that's potassium feldspar. Those sparkly bits, you're going to have some silica in here as well. But because it cooled slower, you're going to have those distinctive little cube-like formations, right? If I get that to focus again. Come on. No, it doesn't want to cooperate. That's fine. So you can see all the different little pieces to it. There we go. Okay. In comparison to my obsidian, which had to cool so much faster, it did not make that same kind of compartmentalized little pieces. Okay. Granite is very important because granite is what the bulk of our continental crust is made up of. So if you are standing on Earth and not in the water, you are on continental crust, and that continental crust is going to be, a major part of our plate tectonics when we do that section. Okay. So now we've looked at an example of intrusive. We've seen some extrusive. All right. Let's see some different types of our extrusive, okay? So again, I've got that lava versus magma. So lava is going to be cooling on the outside of the earth. Magma is cooling on the inside of the earth. Really, the only example I have of our intrusive is going to be our granite, all right? Again, notice how that coarse granular structure we have, that's going to be a big difference when we compare it to some other ones. The remaining 4 I have today are all going to be, again, examples of extrusive igneous rocks. Okay, so let's see some of the wide varieties of extrusive igneous rocks. And I think, wait a minute, those are 4 completely different rocks. I thought you said all of these were made from molten magma. That doesn't make any sense. How can they all be made from molten lava if they look so different? Well, let's compare these 2, for example. This is scoria, or if you grew up in the suburbs in the 1970s and 80s, it may be what was in your front yard. I know that was my front yard, was this lovely lava rock here. Okay, so if I look at scoria, you'll see it's all full of holes, right? Lots of little holes, little pock marks all over it. Okay, and similar to our obsidian, this is, of course, again, extrusive. It had to cool very fast. The difference is there were air pockets inside this guy. Okay, it's very light. If I want to bounce it around, I'm not going to bounce it too much since I am, at a desk on camera. In fact, pumice stone, of course, people now purchase pumice stone that a lot of it is artificially made, but a lot of the original pumice or natural pumice you get is also rock, right? It's very similar to scoria. In fact, scoria is a little bit denser. It's a little heavier, but if you were to grab a pumice stone from your bath supply, it would have that same texture and all those little tiny dots in it. So what happened here is this one cooled on the surface, but didn't have air trapped. This one did. And this one was launched so fast and rapidly from a volcano, again, a volcanic eruption, a very fast, explosive one, that all those air bubbles popped. Basically, scoria is like the popcorn of the rock world. Don't eat it, but think of it that way. All right. Obsidian comes from more slower erupting volcanoes, and scoria is going to be a lot faster erupting. Again, kind of think of this exploding out of your volcano. All the air bubbles go poo. Again, it's like popcorn. Okay, so both of these are extrusive igneous rocks, but they look very different because they cooled under different circumstances. And that's a big part of what gives our intrusive versus extrusive igneous rocks, their characteristics, is the rate at which they cooled. The colors is going to come from its different types of minerals. Again, we had our pinkish hue is going to be your feldspar. All right. Then I have one here. This is basalt. All right. Kind of a dark, bland color. And basalt is very low in silicon. Okay. If I look at it up close, it doesn't really have anything very interesting about it. It's kind of just a plain gray rock. But this plain gray rock is very important. In fact, if you like oceans, you should especially like this guy. Basalt is what all of our oceanic crust is made of. Okay. Again, our crusts on our planet are made up of continental versus oceanic tectonic plates, and basalt is going to be all of our oceanic. It is still extrusive, right? Versus my granite. So this is continental crust. This is oceanic crust. This is intrusive igneous, internal intrusive, right? This is my extrusive, external extrusive. So these guys cooled from being snuggled up inside the Earth's surface, and we had to mine them out. Basalt and other extrusive, well, especially basalt, these come from the fissures inside the oceanic ridges. So, for example, the Mid-Atlantic Ridge is a major ridge running down the middle of the Atlantic Ocean. So all of these ridges kind of open up and all these guys kind of ooze out. And then they slowly cool on the surface of the ocean, right? Or the bottom of the ocean, I should say. So because this cooled at the bottom of the ocean, you can see it still looks very coarse, right? Well, especially, there we go. It looks very coarse. It doesn't have that glassy structure the way obsidian does, but it also doesn't have that popcorn look the way that scoria does. Even though it is extrusive, because it was surrounded by water, it had to cool at a different rate. Okay? And then our final example here is going to be rhyolite. Now, rhyolite is an interesting one. It's not one that I usually talk about. Rhyolite, when I first got the sample, I was like, they totally mislabeled this. How can this be an igneous rock, right? Well, the interesting thing about rhyolite is basically the extrusive version of granite. Okay, they have the same chemical composition. So they're going to have quartz and they're going to have alkali feldspar. Okay. And the difference, if you kind of go side by side, right, is going to be in how fast they cooled. If I can get them to focus, right? You don't see that nice, I think it isn't like, there we go, get that to focus better. It doesn't have that same chunky look the way that granite does, the little individual pieces. It doesn't have that because this is going to cool a lot faster. So it doesn't have the time to create those fine-grained or coarse-grained crystals the way that granite does. So rhyolite, again, the same mineral component as my granite, like my mineral component is the same. The difference between these two is this one is going to be an extrusive, and this one is going to be my intrusive. Okay, so if I compare all of my lovely little igneous rocks together, okay, so remember all these 5 are all examples of igneous rocks. There are, of course, many, many, many more. These are just the ones that I happen to have samples of. Okay, igneous, again, being born from fire. All of these started out as being molten, as being liquid. All right, and then your big categories are going to be extrusive versus intrusive. Okay, which is going to be lava versus magma. Right, when it's outside the surface, it's lava. When it's inside the surface, it's magma. So intrusive lava, intrusive magma. And in terms of these 5 samples here, you're going to have all these guys are going to be team extrusive, and I should really buy some more intrusive samples. But this just gives you a brief example of all of our different igneous rock characteristics. Of course, as you can see, there's a vast amount of diverse characteristics within this rock category, and then we'll also have videos about your sedimentary and metamorphic as well. Remember, within a rock's life, they get recycled over and over again. And so what might start out as a piece of granite might get turned into a different type of rock later on. Thank you so much, and email me if you have questions.